welcome to another class of microwave engineering. Today we are going to study the S parameter. What are the scattering parameters? Scattering parameter are used for the analysis of microwave or RF circuits or systems. Basically, it's a mathematical representation. Representation of RF energy that propagates in any RF system. Then the question arises, why we are interested in the new parameters, although we have, let's say, Z parameter, we have H parameter, we have Y parameter, we have A, B, C, D parameter for the analysis of the circuits. जिस तरह हमारे पास है कि for example, the example of the Z parameter is, let's say, Z11, Z12, Z21, Z22, and this is an example of, let's say, the Z parameter. The reason is that for this is that in RF system, voltage and currents are difficult to measure Number one reason is that difficult to measure, or it's not possible to measure. Okay, ji. The second reason is that the open and short conditions are not available. What is meant by this thing, I will explain it in a minute. Like if we have, let's say, have an amplifier. Let's consider we have got an amplifier and we want to measure something, and if we want its output to be open or short. So what will happen that this amplifier may start oscillating or it become unstable. So when it become unstable, it is not functioning as an amplifier. It's not functioning as an amplifier. So the reason that we use S parameter for the analysis of the RF system is because that voltage and current are not possible to be measured. Open and short conditions are not possible, and it may lead to instability of the system. Now we come to what are S parameters. Consider a two-port network. Let's say consider a two-port network. Let's consider we have this two-port network. NW stands for network, and network. It has got two ports. This is port 1 and this is port 2. Port 1 and this is port 2. Anybody, what is meant by port 1 and port 2? What is meant by ports? Anybody? Input and output. Yeah, the ports through which we can get an input or an output. We call it port. Okay. So now consider that this is a 2-port network, and we have this port 1 is indicated by 2 lines and port 2 is indicated by 2 lines. We call it P1 and we call it P2. Then we write A1 over here and A2 over here, B2 over here, B1 over here, and B2 over here. What's A1? A1 is the RMS of incident wave, RMS of incident wave. It's the RMS voltage of the incident wave. Similarly, B1 is of reflected wave. A2 is of, and it is at port 1. At port 1, at port 2 of incident wave, at port 2, and B2 is the reflected wave at port 2. Acha, actually, whenever a device is connected through via ports, so what will happen that the power is flowing into the port, and this power flow through the device and it comes out from the other side. And if the device is not perfectly matched, then what will happen? Then there is some reflection from the input port. There is some reflection from the input port. Sir, ये बात A is the term. A is the term that shows. A stands for shows incident wave. Incident wave into the 2-port network, into the device कह दें आप. ठीक है जी. A जो जहां पे भी आप A देखेंगे, A is always input. A is always input into the device or into the network. ठीक है जी. B, wherever you see B, it is reflection. It stands or shows reflected wave out of the device or from that port. ठीक है जी. फिर यहाँ पे सबस्क्रिप्ट आ जाते हैं, whether A1 इसको AI कह लेते हैं, जनरलाइज के AI कर लेते हैं. AI subscript shows the number of the port. ठीक है जी. अब अगर A1 है तो incident wave at port 1. If it's A2, then it is an incident wave at port 2. If it's A3, then it is the incident wave at port 3. If it is A4, then it is an incident wave at port 4. ठीक है जी. Similarly, B1 है तो it is a reflected wave from port 1. B2 hai, it is the reflected wave from the port 2. So if you see this figure, you see this all A are into the device. A are into the device and all B's are out of the device. Or basically it is the reflection or the wave coming out of the device. ठीक है जी. A की direction हमेशा into the होगी या into the device or into the network, and B will be always away or out of the network. ये clear है? अच्छा, फिर आगे जाते हैं जरा. So what's the relation? What's the relation between this incident and a reflected wave? This is in this form that B1 is S11 A1 plus S12 A2 okay, and B2 is S21 A1 S22 A2, and in matrix form we are going to write it like this: B1 B2 and S11 S12 S21 S22 A1 A2. It's like this. अच्छा, तो ये अगर इसमें हम देख लें, ये S11 सबस्क्रिप्ट में दो टर्म्स आ रहे हैं 11. So this one indicate the input port and this one indicate the output port. ठीक है जी. Similarly, if it is S12 or S21, this one indicate the input and this will indicate the output. It will become more clear in just a minute. अच्छा, तो basically हम क्या कर रहे हैं कि we have written a relation for two-port network in term of reflected, incident and S parameters. Okay. Now consider this is a condition. This is again a two-port network. This is A1. This is B1, and this we connect a Z0, and this is A2, this is B2, and again this is the same two-port network. This is again the same two-port network. Now at port 2, P2, we have terminated the port 2 with the characteristic impedance. P2, port 2 is terminated with characteristic impedance that is of Z0. ठीक है जी? So if the transmission line, you already know that if the transmission line has got a characteristic impedance Z0, if the transmission line has the characteristic impedance of Z0 and it is terminated into the characteristic impedance into ZL, that is equal to Z0. So what will happen, that all the power is absorbed, all power is absorbed by load ZL. When all power is absorbed, so it means, what it means, that there is no reflection. तो जो भी चीज है सारी की सारी, anything that is coming out of this two port, and what is coming out is of this two port device is B2. It passes through this Z0 and it is completely absorbed by Z0. And when it is completely absorbed by Z0, under this condition, this A2 becomes 0. So there is no reflection. So when there is no reflection, so this A2 becomes 0. So look at this equation. Let's say I call it this equation 1 and this equation 2. Now look at equation 1. When this A2 0, this term reduces to 0. And so S11 become B1 by A1 under the condition that A2 is equal to 0. S11 is equal to B1 by A1 when A2 is 0, and when A2 is 0 only, when it is terminated, the port 2 is terminated into the characteristic impedance, which I have already written over here. Okay. Which one?
सर ये अभी जो आपने बोला सर,
ये देखें कि हमारे, अब ये देखें कि अगर हमारे पास टू पोर्ट, अगर कोई डिवाइस है, कोई एम्पलीफायर है, उसके इनपुट पे हम पावर देते हैं, ठीक है जी, और वो उसका आउटपुट इज परफेक्टली मैच to the load. So what will happen? All the power will be absorbed by that load. All the power will be absorbed by that load. जब absorb होगा तो रिफ्लेक्शन वहां से नहीं होगी, लोड से कोई रिफ्लेक्शन नहीं होगी. जब लोड से कोई रिफ्लेक्शन नहीं होगी, सो ये देखें कि फिर A2 0 हो जाएगा, ठीक है जी. Now consider this another one, कि S21 जो है, S21 अगेन इस दूसरे इक्वेशन में देखें, ये भी हमारे पास ये टर्म 0 हो जाएगी, और S21 किसके बराबर आ जाएगा? S21 जो है ये बराबर आ जाएगा B2 by A1. Again the condition is A2 equal to 0. S21. Okay, what is S11 and S21? I will be explaining it, but we are moving it stepwise. We are moving it. Okay. Now next slide is, again I'm going to write this equation. मुझे दोबारा राइट करनी पड़ेगी. S11 A1 plus S12 A2 B2 S21 A1 plus S22 A2. This is equation 1, this is equation 2, and if this is our two-port network again, this is P1 and this is P2, and here we have A2 and here it is B1. Here it's B1. So, and this is here is A1 and here it is B1. So now instead of port 2, we terminate this port 1 by the characteristic impedance ZL is equal to Z0. So what will happen, that all the power that is going through this will be absorbed and there will be no reflection. So A1 will reduce to 0. A1 will reduce to 0. So when A1 reduced to 0, see this thing that this and this one become equal to 0. So BS12 is equal to B1 by A2, A1 equal to 0, and S22 is B2 by A2, and SA1 is equal to 0. Okay. Now, what is S11? Again, we have already written this thing that S11 is B1 by A1, and when A2 is equal to 0, S21 is B2 by A1 when A2. So S11. S11, we call it input reflection coefficient. It is input reflection coefficient. Input reflection coefficient. ठीक है जी. Input reflection coefficient. Okay, this is input reflection coefficient. Similarly, S22 is the output reflection coefficient. Is the output reflection coefficient. S21 is the gain or the forward gain. And it also give us information about insertion loss. ये अभी मैं explain करता हूँ सारे, just bear with me. S12 is the called it reverse gain, and again it's the insertion loss. It's an insertion loss. अब अगर consider कर लें कि we have an amplifier. What is the purpose of the amplifier? Why we use amplifier? Let's say we have an amplifier. So what we want to have, we have a signal at the input and we want to amplify at the we want to amplify that signal at the output. We want an amplified signal at the output. So this is the function of an amplifier. So S21 is the gain of amplifier. अब ये देखें, हमने बिल्कुल जो क्या कहते हैं शुरू में कहा था कि this is input This is input and this one indicate output. So the signal at the input and the signal at the output, S21 input and the output. So this S21 is basically the forward gain, is the forward gain. अगर हमारे पास एक्टिव डिवाइस है, एक्टिव डिवाइस का क्या मतलब है कि हमारे पास एम्पलीफायर है, तो फिर क्या होगा कि वो हमें गेन प्रोवाइड करेगा एंड दैट गेन इंफॉर्मेशन is provided by S21. This is called the forward gain. However, if this is not an active device, अगर active device नहीं है, active device अगर हमारे पास कोई filter है, कोई mixer है, कोई passive device है, then what will happen if it's a passive device? Then the input will not be the input or the output will not be greater than the from the input. ठीक है जी, आउटपुट जो होगा पैसिव डिवाइस में, not in an amplifier but in a passive device, it will be less than the input, and this is because that there is some loss into that mixer, passive mixer or passive device or a filter, and this is indicated by an insertion loss. उसे क्या कहते हैं? Insertion loss. Similarly, S12 का क्या मतलब है कि ये हमारे पास इनपुट है और ये हमारे पास आउटपुट है. ठीक है जी, ये हमारे पास आउटपुट है. सो बेसिकली के पोर्ट 2 पे हम इनपुट दे रहे हैं, पोर्ट 1 से हम इनपुट ले रहे हैं. सो बेसिकली इट्स अ रिवर्स गेन. सिमिलरली अगर अगेन कंसिडर एन एम्पलीफायर, और एम्पलीफायर का ये पोर्ट 1 है और उस पोर्ट पे हम इनपुट पावर दे रहे हैं, बट पोर्ट 1 इज नॉट परफेक्टली मैच. इफ द पोर्ट 1 इज नॉट perfectly matched, then what will happen? Then there will be a reflection from that port 1, from that device at port 1, and we will call it input reflection coefficient, and this information will be represented by or indicated by this S11. ठीक है जी. Similarly, S22 क्या चीज है? अगर हमारे पास पोर्ट 2 पे कोई रिफ्लेक्शन हो, पोर्ट 2 पे रिफ्लेक्शन हो, इनपुट पावर आ रहा हो, उसकी वजह से रिफ्लेक्शन हो, देन इट इज कॉल्ड एन आउटपुट रिफ्लेक्शन कोएफिशिएंट. ठीक है जी, इसको अभी ये मजीद क्लियर करवाते हैं. नाउ consider that we have an amplifier. और ये है A1, ये है B1, सोर्स A2 और B2, it is terminated into ZL, that is equal to Z0. तो आइडियली हम क्या चाहेंगे? that there is no reflection from the port 1, no reflection. तो आइडियली हम क्या चाहेंगे कि S11 जो है B1 by A1 0 हो आइडियली. एंड इसको इस तरह लिख लेते हैं, आइडियल एम्पलीफायर. S11 क्या चीज हो जी? के इनपुट रिफ्लेक्शन कोएफिशिएंट 0 हो. सिमिलरली S12 क्या हो? के पोर्ट 2 से रिवर्स गेन की वैल्यू हमारे पास वो भी 0 हो. सिमिलरली S21 जो कि है B2 by A1, जो कि है गेन एन एम्पलीफायर और द फॉरवर्ड गेन, वो इसकी क्या वैल्यू हो? इट्स अ वेरी हाई वैल्यू. और ये हमारे लेट्स से 25 to 30 dB इसकी वैल्यू होती है 25 to 30 dB of let's say LNA, low noise amplifier or any amplifier. ठीक है जी. Similarly, S22 is the output reflection coefficient. Output reflection coefficient. What was S22 जो है, S22 is the reflection coefficient from output reflection coefficient, and again we want this value to be 0. ठीक है जी. एम्पलीफायर बेसिकली पर्पस क्या है एम्पलीफायर का कि एम्पलीफायर जस्ट एम्पलीफाई द सिग्नल, जस्ट एम्पलीफाई द इनपुट सिग्नल. तो वो है forward gain, and that is S21, and it should be very high. The rest of the values should be, all of them should be 0. ठीक है जी. यहां तक समझ आ गया जी आपको. और अच्छा, ये एक टर्म है VNA, that is called